We're going to dive a lot deeper into one of the questions that we mentioned in part 1, and that was, how are these devices interconnected? The common answer is they are connected by an Ethernet cable. Now, not all connections use Ethernet, but Ethernet is the most popular physical layer 1 technology in use today. We will cover the different layers in the next lesson. Actually, let me clarify that a bit, because some protocols operate in multiple layers and Ethernet operates at both layer 1 and layer 2, but that answer is not enough in itself, as Ethernet is a group of standards defined by the IEEE, Institute of Electrical and Electronics Engineers. A cable that sends 10 megabits or 1000 megabits per second is called Ethernet, and even wireless, which has no cables at all from access point to endpoint, although not an Ethernet standard, can appear to be seamless with the Ethernet standard when configured correctly. We're going to look at these Ethernet standards at a deeper level. Ethernet cabling refers to the physical medium that carries network traffic between devices, and it comes in various types, including twisted pair copper cables and fiber optic cables. Ethernet cabling standards. These specify the maximum transmission speed, cable length, and other parameters for Ethernet cables. The following are the most common Ethernet cabling standards. 10BASE-T. This is the original Ethernet standard and provides a maximum data transfer rate of 10 megabits per second, Mbps. It uses twisted pair copper cables and supports a maximum cable length of 100 meters. 100BASE-TX. This is a fast Ethernet standard that provides a maximum data transfer rate of 100 megabits per second. It also uses twisted pair copper cables and supports a maximum cable length of 100 meters. 1000BASE-T. This is a gigabit Ethernet standard that provides a maximum data transfer rate of 1 gigabit per second, Gbps. It uses twisted pair copper cables and supports a maximum cable length of 100 meters. 10BASE-T. This is a 10 gigabit Ethernet standard that provides a maximum data transfer rate of 10 gigabits per second. It also uses twisted pair copper cables and supports a maximum cable length of 100 meters. We also have fiber optic cables that can use either LEDs instead of electrical signals as the light source, which is known as multimode fiber and can travel a distance up to 550 meters, or lasers as the light source, which is known as single mode fiber and is more expensive than multimode fiber, requiring more precise alignment during installation, but can transmit data up to 40 kilometers and has a higher bandwidth than multimode fiber. Let's take a look at some of these fiber standards. 100BASE-FX is an optical fiber Ethernet standard that provides a maximum data transfer rate of 100 megabits per second, Mbps. It uses two optical fibers for transmitting and receiving data and supports cable lengths of up to 2 kilometers. 1000BASE-SX is a fiber optic Ethernet standard that provides a maximum data transfer rate of 1 gigabit per second, Gbps. It uses multimode optical fibers for transmitting and receiving data and supports cable lengths of up to 550 meters. 10BASE-ER is a fiber optic Ethernet standard that provides a maximum data transfer rate of 10 gigabits per second, Gbps. It uses single-mode optical fibers for transmitting and receiving data and supports cable lengths of up to 40 kilometers. These cables connect into the various network devices, and on the end of a twisted pair copper cable we have an RJ45 connector, where one end of the cable with the RJ45 connector will connect into the device's NIC and the other end will connect into one of the ports on the switch. Now, in the real world, you probably wouldn't connect the devices directly into the switch. The switch will be in a separate room, often called a hub room. It will have connections to a patch panel, and those patch panels will have connections to a wall port, and the device will connect to the wall port. But these wall ports and patch panels are transparent to the switch, so it looks as though the device is directly connected. Now, an important point to note is that it doesn't matter if you are using a 10 megabits per second copper Ethernet cable or a 10,000 megabits per second, which is 10G, fiber optic cable. The format of the Ethernet frame remains the same. It has an Ethernet header and trailer with the data encapsulated between the two. UTP cabling. Okay, there's also something else that we have to remember when using copper Ethernet cables. That is, straight-through cables are used for devices that are not the same, and crossover cables are used for similar devices. But why is that, and what does that even mean? If we take a look at this diagram, we can see that if a switch connects to a router, PC, or server, then it should use a straight-through cable, but if a switch connects to another switch, then it should use a crossover cable. And I'm going to explain why that is. If you look at the end of an RJ45 cable, you can see 8 different colored cables connected to 8 pins. However, if we are using 100 base T, then this only uses 4 wires. So we saw previously that we use a straight-through cable if we are going to connect 2 different types of devices. Let's choose a switch and a router. We also saw that there were 8 pins in the RJ45 cable. But only 4 of those pins are in use when we are using a 100 base T cable, which is fast Ethernet. When we are using a straight-through cable, pins 1 and 2 are used to send data, and pins 3 and 6 are used to receive data, and the roles are reversed on the other side. This means that both devices can send at the same time and receive data at the same time. This is called full duplex transmission. These are called straight-through cables. But what will happen if 2 routers wanted to communicate with each other? It's simply not going to work with straight-through cables. The answer to this problem is another type of cable, the crossover cable, where pin 1 is connected to pin 3, and pin 2 is connected to pin 6 on each end. Here's a chart reviewing the different devices and pins that they use to receive and transmit data. However, if we were to use speeds greater than fast Ethernet, like 1000 base T or gigabit Ethernet, then all 8 pins will be used. This is the layout for a straight-through cable, and this is the layout for a crossover cable. CSMA-CA versus CSMA-CD. With CSMA, the C stands for carrier and the S stands for sense, where the devices are listening to see is anybody sending information at the moment. The MA stands for multiple access, which means that more than one device is using that shared medium, more than one device is connected to the network. Now, there used to be an issue in the networking field where network devices were connected via something like a hub using half duplex. This meant that only one device could communicate over the network at a time. Many of the devices that are used nowadays connect via switches which use full duplex, meaning multiple devices can connect and communicate all at the same time. But with CSMA/CA, the CA stands for collision avoidance and is mostly used with wireless 802.11 networks. The device will send its intention to transmit across the shared media or the Wi-Fi channel, and if the channel is clear, it will send. If not, it will back off for a random amount of time before trying to send again. CSMA/CD stands for collision detection and is used after a collision has already been detected on the network. This is mostly used in wired Ethernet 802.3 networks, and when a collision is detected, it stops sending until the medium that it is sending across becomes free. After sending the frame, the device monitors the wire to ensure that the frame was sent successfully, and if not, it will send the frame again. Now, it's question time. 1. What layer of the OSI model does the Ethernet standard sit at? A. Layer 1. B. Layer 2. C. Both Layer 1 and Layer 2. D. Layer 4. The answer is C. 2. What is the definition of Ethernet? A. A protocol with a set of standards allowing wired devices to communicate. B. A protocol with a set of standards allowing both wireless and wired devices to communicate. C. A protocol with a set of standards allowing wireless to communicate. D. Ethernet is just the cables. The answer is A. 3. What speed and media type does gigabit Ethernet run at? A. 100 megabits per second, 1000 base T. B. 1000 megabits per second, 10G base T. C. 1000 megabits per second, 1000 base T. D. 10 gigabits per second, 10 base T. The answer is C. 4. What is the maximum distance a fiber Ethernet cable can travel? A. 100 m. B. 550 m. C. 2 kilometers. D. 40 kilometers. The answer is D. 5. What type of cable would you use to connect a router to another router? A. Crossover cable. B. BNIC cable. C. Straight-through cable. D. Single-mode fiber. The answer is A. 6. What does CSMA stand for? A. Collision sense multiple applications. B. Carrier sense multiple access. C. Collision sense media access. D. Carrier sense media access. The answer is B. 7. What is the difference between collision avoidance and collision detection? A. Collision avoidance waits for the channel to be free before sending. Collision detection waits until after a collision has already happened. B. Collision avoidance waits until after a collision has already happened. Collision detection for the channel to be free before sending. C. They are the same thing except one is for the wireless standard and the other is for the wired connections. D. None of the above. The answer is A.